Going to look at angle measures. We're going to talk about describing angle measures and what makes up an angle. First off, what is an angle? An angle is a union of two rays with a common endpoint. So here you have an angle where the two rays come together, where they join together, would be called the vertex of the angle. Angles are made up of generally two different pieces. We have the inside, which is the interior, all points that lie inside the rays. So the red here would be called the interior of the angle. And then the exterior is everything that's on the outside of the angle. So this would be the exterior portion of the angle in blue. From there, naming an angle, very similar how we name points, lines, and planes. We do need to be able to name an angle. When you name an angle, you name it by the vertex. So this here would be called angle A. Angle A. You could also call it angle BAC. You cannot call this one by the vertex because here you have two different angles. You have angle BAC and angle CAB. So you have two different ones, so you can't call it by the vertex. So here we can call this angle A, but it only works sometimes if it's a standalone angle. We can also name an angle by using 3 points with the vertex in the middle. So here we have angle BAC, kind of like I mentioned before, and the same angle would be angle CAB. Understand that the vertex is in the middle both times you name those. From there, you can kind of name both of these angles. Here we have angle BAC and angle CAD. So now we have two different angles. We have one here, angle BAC, and a separate one here. There is a third angle, angle BAD, and that is here. Right here. So now you have three different angles seemingly within of one. We can also name them by using numbers. Sometimes we can just we can place a number there if there's not one already, and now we can call this angle 1 and angle 2. And it makes it a little bit simpler to be able to name an angle if there's a lot of angles that you're looking at. So here, instead of saying all of these letters, I could just say angle 1 and angle 2. So here we have angle 1 and angle 2. Angle measure. And what is an angle measure? It's literally telling you how open how open something is. The measure of openness, it's measured in degrees. And whenever you measure an angle, you use a protractor. And I'm going to show you what that looks like in a couple minutes. So there's a couple different categories of angles. Angles are measured in degrees. Little degree symbol here. We have an acute angle. That's an angle that goes from 0 to 90 degrees. It's greater than 0, so like 1 degree, and then less than 90, like 89. We have an obtuse angle that is greater than 90 degrees and less than 180 degrees. Now that's all fancy and all, but I guess we would have to know what a 90-degree angle looks like. So here, this is a 90-degree angle. You usually see these in corners, on boxes. Most things in our world are 90 degrees. So here we have a 90-degree angle. Also known, we would say that this line here is perpendicular to this one. This little box that's been placed here means that it's 90 degrees. So if I had an angle that went like this, this would be less than 90 degrees. And then if I had an angle that went like this, this would be greater than 90 degrees. From here all the way to here. The last one that you didn't get to look at said a reflexive angle, and that's greater than 180 degrees. Think about what are the 180 degrees. It's when you have a straight angle, and I'll show you what that looks like as well. But greater than 180 degrees is going to give you reflexive. So once again, a right angle. Here you have a right angle where this is 90 degrees. That box means that it's 90 degrees. This means that it is perpendicular. So this right here, it shows it's 90 degrees. That's a big deal. You have to be able to realize that that does mean 90 degrees. Sometimes you'll just have that as in the image and then nothing else. To answer a question, maybe we'll see that a little later. So here we're going to take a look at how to use a protractor and all of that good stuff to find the measure. This reads the measure of angle SQR. Sometimes you see it written like this with a little mark that goes through here as angle, just because sometimes when people write it, it looks like an L. So oftentimes you see it looks like this, but this reads the measure of angle SQR. And to do that, you take your protractor, you place the center right here of this protractor on Q, on point Q. And then you look at this and you say, okay, well, and your line looks to be right about here. Perfectly lines up. And for the sake of seeing what it looks like, here, this is at 46 degrees. Now some people are wondering, how do I know if it's 46 degrees or if it's 134 degrees? Great question. The reason I know that off the top of my head is because first off, we would be able to say from our previous slide that this is 90 degrees. When it's perpendicular, would be 90 degrees. And I think to myself, is this angle less than 90 degrees? Yes, it is. So that means I know I'm going from 0 all the way up. Now if it was over here, if my line extended this direction, and from R all the way over, it would be 130 degrees. So that's how I take a look at that. We have a couple special angles because it does open the openness. Sorry, it does measure the openness. If the rays are both going in the same direction, here we have angle BAC. That means actually that A is the vertex. That's a 0 degree angle. We also have a straight angle. Looks like two opposite rays. Here we have angle XYZ. These are kind of special. They look very similar, but they're not the same. And to take a look at that, if you look here, just this real quick example of what I mean by that, this would be a 0 degree. Here you have both of them going this way. And then if you opened it up, now you would see that this would be a straight angle. And if you kept going all the way around, so here we go from 0 degrees, 10, 20, 30, 90, 130, 150, 160, 170, 180 degrees. And if we kept going past that, like this way, it would go from 0 all the way to 180 plus some more. And that would give you that reflexive angle that we were talking about earlier. So then here this says find the measure of angle WST and the measure of VSU. So first off, when I look at this problem, I think, what am I trying to find? Measure of measure of angle WST from W to S to T, which means I'm looking for this angle here.
Ms. Key, or someone from daycare, please check by the front office. Thank you.
I'm also looking for the measure of angle VSU from V to S to U. Please note how I physically touch the paper to find out which angle I'm talking about. So I'm also looking at this angle here. Now there's a couple things that I do need to realize when I'm looking at something like this. First off, I'm going to think to myself, well, what does this mean right here? That's right, it means 90 degrees. So now I know that this is 90 degrees. What else do I know? What else do I know? I know that this line right here is a straight angle. All of this from here, let's go a different color, let's go blue. From here all the way to here is 180 degrees. So that opens up 180 degrees. So if I think about it like this, the whole thing is 180. This is 90 degrees. How much is left over? Well, 180 minus 90 is equal to 90. And so, angle VSU is now 90 degrees. I'm going to go ahead and write that down. The measure of angle VSU is equal to 90 degrees. From there, I try to figure out what is angle WST. To do that, you use a lot of the same information, but here, V to S to T is still 180 degrees. All of this is 180 degrees, so all of this angle is equal to 180 degrees. I don't know WST. I'll call it angle 1. I'll call that angle 1. This will be angle 2, but it's already had degrees. So here I'm thinking to myself, well, angle 1 plus angle 2 is equal to the whole thing. Well, I have angle 1, hopefully I can write it a little nicer, plus, how much is this? 35 degrees, and that's equal to 180 degrees. Solve for angle 1, subtract 35, subtract 35, angle 1 is equal to 10, 5, 4, 145. So WST is 145 degrees. Thanks for showing up. Thanks for being awesome.